pins and extract full. I mean, extract a full refresh. Something is showing there now. That's here. It's not available here. That's why I'm
Every
asking.
time, say this is the first stage of connecting the data source, right? Every time you cannot come here and do refresh, right? Every time you cannot come here and extract your file. So now you go to the sheet. Go to the sheet.
This sheet,
Sheet 1.
sheet one. Okay.
Okay. Now you
Okay.
make some changes in that sheet, like in the database. Go to open that file, extract whatever you have created file.
Okay.
I'm asking open the file whichever you have created, not this. Go to sheet. Where you have saved that, and somewhere you created that file, right? Products
Notepad.
and series.
The notepad or the text format.
Where have you saved that file? Not here. Are you in your desktop or in your downloads? Why are you going again to data source?
No. Can you open like extract text file in the desktop where you have saved? Go to the
Where
file.
did you save that?
Sorry.
ఆ సేవ్ ఎక్స్ట్రాక్ట్ టెస్ట్ అనేది ఆడో చోట సేవ్ చేసి ఉంటావు కదా నువ్వు.
నోట్ప్యాడ్ సేవ్ చేశాను అదే.
ఆ నోట్ ప్యాడ్ ఓపెన్ చేయండి అన్న. యాడ్ సేవ్ చేసినావు. Have you saved in your desktop or in download? Somewhere you have saved, right? So open
documents.
that. Open that file. You opened?
Yeah, I opened this one.
Okay, I cannot see it. I'm seeing blank screen there. Okay, so you make some changes now.
Yes.
And save it and refresh the database again. Refresh the Tableau file again. Remove that. So why have you come to data source again? I asked you to be in sheet 1.
Sheet 1.
Where is it changed? What have you made change?
Just added T here.
Okay. So go to sheet now.
Okay.
Now you open that file and do the change and save it.
I have to open the file here.
Open that file. Whatever you have done now.
Okay.
Open it again. That notepad file. Make some changes here. And save it.
I have to make some changes here.
Save it.
I saved that one. Then.
Okay. So now you refresh here. So where do you have that button? So every time going to data source instead of data source, going every time to the data source tab, you can do it here itself, right?
Yes.
So that is the refresh where you can connect it at the first time. When you connect to the file.
Okay.
If you made any changes, you can do the refresh there.
Okay. Here I have to refresh.
So in between, see, the good thing about the Tableau is Tableau will allow you to do the same task in multiple ways.
Okay.
Nothing is wrong. Either you do here or you do there. It's all about up to you how you decide.
Okay.
Okay. So now the file is refreshed. Now you view the data. Where do you have the view option?
Yes.
Is that the view option? I had showed yesterday.
View option.
So there is a view button, right, next to dimensions.
Next to dimensions. Yes. Yeah, it's open.
So every time no need to go to the data source page, and every time you no need to refresh it. Okay. So here itself you can do that.
Okay.
Yeah. So
Thank you.
yeah. So what have we discussed yesterday? We discussed about data connections, right? And let's see if something I missed. Okay. So today we'll see about dimensions and measures. So what is the dimension it is taking and what is the measures it is taking. Okay, so when you connect, how it has been identified, what is being considered as dimension, what is being considered as measure. Okay, so let me view the data. So what kind of data is the sample superstore? Okay, so this is the sample superstore data. So what are the fields it is having? So it has category, it has city, it has country, region, it has customer name, manufacturer, it has order date, it has order ID, it has postal code, it has product name, right? It has the region, it has segment, it has ship date, ship mode, state, and it has subcategory, it has discount, it is number of records. Again, it is being generated by Tableau, and profit ratio, quantity, and sales. One second. Hello. Data that is available in sample superstore. Okay. So this data has been segregated as dimensions and measures by Tableau. If you see customer name, segment, order date, order ID, ship date, ship mode, country or region, state, city, postal code, category, subcategory, manufacturer, product name, region. So these are identified as dimensions, and whereas discount, profit ratio, quantity, sales. So these are identified as measures. So what does that mean? How the Tableau is identifying? So let's see that. Okay. So first, what are dimensions? So dimensions and measures have been segregated by its data type. Okay. So based on the data type, the dimensions and the measures have been segregated by Tableau. So for example, all the data type as string, that means textual data, like alphabets. So all the words, string, text data can be identified by Tableau as dimension. Okay, and the date fields. So if your database or data source is containing any of the date fields, then it is identified that field as dimension. If your data is containing any geographical locations, okay, so those will be identified as dimensions automatically by Tableau. So these are the three data types where it is considered as dimensions. And measure, what is measure? So measures, in your data, if there is any numbers, right, like values, then it is considered as measure. And if your data is containing any percentages, even those will be considered as measures. Like any decimal points, like 0.5, like 0.7, or any decimal values, if your data is containing, even that will considered as measure. Okay, so these are the dimensions and measures how Tableau will consider. So if you see in this sample superstore, so what is the first one? Category. So what is category? What is the data type of category? Is it a number?
String.
So it is a textual value. It is a string. So that's the reason category is been identified as dimension. So if you see category, so yeah, so here, so category is under dimension, right? Similarly, city. City is what? It is a geographic location, right? So as I said, geographical locations also identified as dimensions. So city is here. And then country. Country is also, again, it is a geographic location. So again, country is also there under dimensions. Customer name. So what is customer name here? Is it numbers or string?
String only.
That is string again. That is a textual data. Right. So that's the reason customer name is also identified as dimension. And manufacturer, same dimension. And order date. So this is a date. So any date fields will be considering as what? Dimensions. Right. So even the order date is also considered as dimension. And order ID. So if you see the order ID, it is alphanumeric value. So it has the alphabets, it has the numbers, it has the date, right? So this kind of even alphanumerics also can considered as string values. Okay, so this is also considered as string. So it will also be identified as dimension. And postal code, though it is a number, right? 42420 or 90036. This is a number, but still it belongs to geographic location, right? Postal codes are geographic locations. So even this will identify as dimension. And product name, again it is a text. So dimension. So region again south, east, west, north, central. So again it is identified as dimension. Segment is again string, so it is also dimension. Ship date, so again date field, so all the date fields are dimensions. And next ship mode is also like second class, standard class, so this is again a string, so dimension. State, Kentucky, California, Florida, right? Washington, Texas, so this is again geographic location, geographic field, so this is also a dimension. Subcategory is again text, bookcases, chairs, labels, so this is also considered as dimension. Discount is of percentages, so all the percentage values will be considered as measure, so that's the reason discount you can see under measures. And number of records, leave about it. So profit, so all the profits are again numbers, 42, 227, 383, right? So all these values, so values and numbers will be considered as measures, so profit you can see under measure. And profit ratio, again percentages, so it is again under measures. So quantity are numbers, 2, 3, 2, 5, 2, 7, so these all are numbers, so all the numbers are measures, so again it is identified as measure. And sales, so sales also again numbers, like 262, 732, 15, so all the numbers are measures. So likewise Tableau is identified based on the data type in your data source. Okay, so that's the reason you can see here customer name, segment, order date, order ID, ship date, ship mode, country, state, city, postal code, category, subcategory, manufacturer, product name, region. So all these are identified as dimensions. And when it comes to measures, discount, that was in percentages, profit, that was in numbers, profit ratio, again percentages, quantity was numbers, and sales was numbers. Okay, so these all are identified as measures. Okay, so another thing you need to observe here is, so the every field it has some symbol with it, right? ABC. So what does that mean? So ABC indicates it is a string value. Okay, it is a text. So customer name and segment are ABCs, that means they are string values. And for order date, if you see, order date is having what? Calendar symbol. That means this is a date field. Okay, and similarly you can see all the locations with globe symbol. That means these all are geographic fields. Okay, and this is a group symbol, we'll see that later. And so this is a histogram symbol, we'll see that later. So right now, so it is ABC, which is containing the text value, and the globe symbol, which is containing geographic fields, and date symbol, calendar symbol, which is containing the date fields. Okay, and for all measures, it is showing it in number symbol, hash. That means that is a number symbol. Okay, so if any number symbols, then it will show it like this. And the color, if you see the color, all the dimensions are in blue color, all the measures are in green color. Okay, so along with these symbols, you may also find sometime calendar plus watch. That means you have here what? Date plus time field. Okay, so here in our order date or ship date, we have only the date field, we don't have time here. So that's the reason it is showing only the calendar symbol. But if you see calendar symbol with the clock symbol at the corner, that means that field is date plus time field. Okay, so any doubts in this?
No doubts.
Okay. So give me 1 second. Of measures we have. Okay, so yeah, so we have types of dimensions. So what is the types of dimensions we have is, like first dimension we have is slowly changing dimension. So what does that mean? So the name itself says the dimensions which will change over the period of time. That means the dimensions will not change very frequently. Okay, so it will be changing very slowly or very often. So what kind of data it is? Like yesterday we had seen like student information, employee information, right? So this data will not be changing very frequently, right? So this kind of dimensions will be called as slowly changing dimensions. So this is for your understanding. So because you should know what kind of dimensions we have in our database and how they behave. So it will help you in taking some calls. Okay, so rapidly changing dimensions. The second one is rapidly changing dimensions. So the name itself says the dimensions that are changing very frequently. So it will be keep changing, right? So what kind of dimensions those are? Like for example, population, as we see in that. So populations will be keep changing every now and then, right? And even the age. So every day your age will be increasing for a day, correct? Or if it is something like a deadline, so every day you spend, so it will be reducing in your lifespan, right? So it will be updating every day. So such kind of rapidly changing dimensions we have. And unchanged dimensions. So there are few dimensions which will never change. For example, like dimensions are consistent that will not change anytime. For example, name. So once if we keep any name for a person, unless very rare cases, his name will not get changed, right? Even his parent names. So parent names like also will not change maximum of the time, and the gender. It's a very rare case if they're going for a trans, otherwise no, right? So like this, we have some dimensions which will never change. Those are called as unchanged dimensions. And we have conformed dimensions. So that means one dimension will be sharing between the multiple other dimensions. Okay, so for example, the office working hours, let's take about 9 to 6 is a office hours. So again, that is a time. So time will be considering as dimension. So that dimension is having 9 to 6, and that same timing is being used by multiple business segments. Like let's say HR department will use the same timings, sales department will use the same timings, accounts department will use the same timings, right? And technical team will use the same. So that means maybe a shifts will be there, but if you talk about in general, so one dimension 9 to 6, that means it is 9 to 6 for everyone, right? So like that, a single dimension can be shared across multiple dimensions. So those kind of dimensions are known as confirmed dimensions. And a role playing dimension. So what is a role playing dimension? So one type of dimension is playing multiple roles. For example, let's take one date field. So you have a date field, okay? And if you take about Amazon website, so when you place any order, how the date is playing multiple roles there. So first, when you place the order, you will have what? Order placed date, correct? And after a few days, what happens? You will be getting a shipped date when the product is shipped. And after a few days, what you will get? You will get a delivery date when the product is being delivered. And later, if you are returning, so it will show the return date when the product is returned. If it is any refund issued, so when the refund is issued. So again, that is the date. So here, a single dimension, that is date, is playing multiple roles here. So one place it is playing order date, second place it is playing shipped date, and next the same date field is playing delivery date, and then a return date, and finally refund issue date. So one date field is playing here multiple roles, right? Such kind of dimensions are known as role playing dimensions. And shrunken dimensions. So what is shrunken dimensions? Sub part of dimensions. So for example, if you look at the Tableau, so there are some dimensions where it will have a shrunken within the other dimension. For example, you drag the country and region into rows. Okay, so here if you see the plus symbol here, that means there are other dimension shrunken in this. So if you click on the plus, country will be yielding the state field. See, from country we got the state, and still state is also having plus symbol. That means still there are shrunken dimensions. So click on the state, you will get the city. So click on the city, you will get the postal code. See, postal code doesn't have any plus. That means this is the last layer. So if you want to shrunk them back, so click on this minus and click on this minus. So that means they are shrunken into the one dimension, right? Such kind of dimensions are known as shrunken dimensions. Like you cannot have that for customer name, for example. So if you drag the customer name, say you don't have that plus symbol. If you drag the segment, you don't have that plus symbol. If you drag the ship mode, you will not have that plus symbol. Okay, but if you have so Tableau will automatically create them for the date field and as well as the location fields by default. So all the date and location fields are shrunken dimensions. Okay, so similar, we had seen the location. Now if I drag the order date, so if you see, when I drag the order date, see, it is showing all the year and it is showing the shrunken symbol here. So if I click on the plus, from here I can get the quarter. like Q1, Q2, Q3, Q4. And if I click on the quarter again, I'll get the month like January, February, March, April, May, June, July, August, September, October, November, December. And if I click it here again, I'll get the days. Okay, the 30 days, whatever is there. So that means this is again a shrunken dimension. So if you want to shrunk them back, so click on this minus, so it will be hiding it again. Okay, so by default the date fields and the location fields are considered as shrunken dimensions. And degenerated dimension. So what is degenerated dimension? So if a dimension contains only primary key and no text data, then it is known as degenerated. For example, what happens in your database? So it is not completed database. It is a half completed, semi-completed one. Something like you have the student ID information, like the IDs are AA01, 1, 3, 4, 5, 9. So these are the IDs, student IDs, but you don't have the information of the student name or student location. So who belongs to this ID AA01? Who is it? It should belongs to some particular student, right? But you don't have that information. And student ID 1, student ID 3. So who are those? So you have only one dimension which is not completed. Like so, such kind of dimensions are called as degenerated dimensions. That means they are having only one primary key and no text data containing for that. Okay, such dimensions are known as degenerated dimensions. And you have inferred dimensions. What is inferred dimensions? It is empty dimensions. So you don't have any value, you have only the heading and the values have been null. Such kind of dimensions you call it as inferred dimensions. And you have junk dimensions. Sometimes what happens, like all unwanted dimensions will be there. So these are the junk, so we don't consider them. So these are the types of dimensions that we have. And you know that ABC shows the textual data, like as we saw that, and calendar, it will show the date fields. Calendar plus clock symbol, if you see, it shows that date plus time field. And if you're seeing any globe, that means that is a geographical data. Okay, and finally the dimensions are non-aggregated values. It contains string or whatever the date and all. So you cannot aggregate them. So aggregate functions are nothing but sum, right, average, minimum, maximum, count. So these all are aggregate functions. So you cannot apply aggregations, like you cannot take sum of chairs, right, or you cannot take minimum of chair, maximum of chair. You cannot take average of chair, right? So you cannot apply any aggregate functions on the dimensions. Okay, so that is about in detail of dimensions. So I can pause for you. Any doubts? Okay, so I'll consider the silence as no or any.
So
any doubts?
Hierarchy is nothing but
the hierarchies are nothing but the shrunken.
Okay. So how to create a folder as you have created? As you can see, I can see that in your sheet, I can see there is directly the folder, the dimension have been defined in the folder format.
Yeah, that is the topmost discussion we'll have it, because that see creating, when we do this is like when we completely done about our Tableau, okay, and when we start, like there are some best practices of Tableau, because here it is having only few dimensions, maybe 10 or 15, right? So it is easy to identify. Sometimes what happens, you should have so many dimensions in your database, so at that time you will get confused of searching for each dimension, right? So in that case you create it as a folder. Let's say all the person names, you'll be putting it in one folder. All the product related information, you'll put it into the one folder. All the geographic fields, you put it in the one folder. All the locations, you put it in, or all the time fields or date fields, you put it into one folder. So likewise, you can segregate your data, like it is something like organizing your data. Okay, so that comes at the end topic, but here Tableau automatically creates few folders which it can identify. So it has identified the customer name and the customer segment into one folder. So it has created a customer folder and created, and order related information it identified as order date, order ID, ship date and ship mode. So these all are it identified as order folder. So if it is correct, you can use it. Otherwise, you can recreate the folders. We'll see them at the end, because that is it comes in a best practices of Tableau. Okay, so if I say now itself, by then you forget it. So we'll discuss that at the time of best practice.
So in short, I wanted to know like this is being created by Tableau.
Yeah, right now I have not done any manual effort here. So I just connected my data source. That's it. So everything is being done by Tableau. So I have not put anything as a dimension to consider. Tableau itself considered all these are dimensions and all these measures and all these folders, all these hierarchies. Okay. So everything is being identified by Tableau automatically. That's the good thing of the Tableau.
So maybe this feature is not available in the Tableau public?
I don't know, because I have not used Tableau public much.
Because I was using Tableau public and I didn't see.
You are not able to see those, is it?
Yes, those
okay.
is not available.
Maybe it is also
I have to manually create it. That's what I was asking. Even I found like in Tableau 20 version, the dimension and the measures which you can see in the bold, those are not.
That means you are using the latest version.
Are not visible.
So in 2020, in 2020 version, the updation is you don't find the dimension and measures, you just find the table. So that is the latest version update. So that's the reason I specifically ask you to download 2019.4, because you should not mismatch in the view, right? So you are seeing something and I am saying something. So that's the reason I asked you to download 2019.4, because that is a version upgrade happened. So the latest version doesn't show dimensions and measures separately like this. It will show only one field, that is called table.
Okay.
Yeah. So let's move to measures. So like dimensions we had seen, we have measures also types. So what kind of types we have is so measures are aggregated values. So we can apply aggregations. Let's say, because we know that sales, for example, so we have the sales information in the Tableau, right, in the data source. So let's say, for example, if you have sales like 100, 200, 300, we can apply all the aggregations to it, like sum of sales. What is the sum of sales? 100 plus 200 plus 300, that is 600. So it will give you the value as 600. And if you ask what is the minimum of sales, then it will show 100 is the minimum out of 3. And what is the maximum sales? That is 300 is the maximum. And what is the average? So average is 100 plus 200 plus 300 divided by 3. That is 600 by 3, that is 200. So that means you can apply all the aggregations on measure values. Okay. So you cannot apply the aggregations on dimensions. Remember that. Okay. But on measures you can apply. So because it is containing number values or percentages, right? So that's why we can apply the aggregations. So that's why we call measures are aggregated fields. Okay. So what kind of measures we have? So we have 3 types. One is additive measure, second one is semi-additive measure, and the third one is non-additive measure. Okay. So what is additive measure? First of all, so when you apply aggregation to the when you apply any aggregation to the measure, the output should have a meaningful. So if the output is giving you a meaningful, then you can say that that is a additive measure. So for example, sales is the measure we have, right? In the above example, we have a measure called sales, and the values we have is 100, 200, 300. So here we apply any aggregation, like sum of sales, it is 600. It's a meaningful output. Minimum of sales 100. Maximum of sales, it is giving you a valid output. Average of sales, it is giving you a meaningful output. So in such cases, like if you apply any aggregation, if it is giving a meaningful output like this, then those are called as additive measures. And there will be some semi-additive measures. So what are semi-additive measures? So it will give meaningful output with only few aggregations, not with all the aggregations. Okay. For example, you have a discount field, and discount field is containing 10%, 15%, 20%. Okay. And here if you see sum of discount, so if you apply the sum aggregation to this discount, so what the output it will give? So 10%, 10 plus 15 plus 20, that is 45%. So is it a valid? So 45 discount is the total, you can say, because it is depends on the independent, right? The discount is, you cannot say like whatever the three values you have, you can sum it and you can say, okay, I'm getting total 45% of discount. Right, so sum will not give you a valid input, valid output when you apply for the discount or for the percentage values. But if you apply minimum discount, so what is the minimum discount here? It is 10%, correct? 10% is the minimum, so that will give you a meaningful output. And similarly, what is the maximum discount? So that is 20%. Yeah, 20% also will give you a valid. And if you apply average of the discount, so what is average? So it is 10 plus 15 plus 20, that is 45 by 3, that is 15% is the average discount you will get it. So even that is a valid output. So if it will give the meaningful output only with the few aggregations, not with all the aggregations, then in that case those measures are called as semi-additive measures. Okay, and the last one is non-additive measures. That means it will not give any meaningful output with any of the aggregation. For example, all the decimal values. So decimal values will not have any meaningful output when you apply the aggregations. Okay, so these are the three types of measures we have. Additive measure, so it will give meaningful output with all the aggregations. Semi-additive measure, it will give meaningful output with only few aggregations. And non-additive, it will not give any meaningful output with any aggregation. Okay, so what are the aggregations we have basically? So we have sum, minimum, maximum, average, count distinct. Okay, so how you do that is, so let's go to the Tableau. So here if I drag any measure, okay, so measures are discount and all, right? So I am dragging sales. See, I am dragging sales, but it is taking sum of sales, correct? So measures are aggregated values. By default, Tableau will apply the suitable aggregation for it. So if it is taking sum, that means it will give meaningful output for any aggregations. Okay, so this is called additive measure, sales. And even if you drag the profit, see, it will take sum of profit. That means even this also additive measure. If you drag the quantity, see, again it is taken sum of quantity. That means even this also additive measure. But when you drag the discounts are percentages, right? So if you drag the discount, see, it is taken average. That means sum of discount is not a valid output that you get. So that's the reason Tableau is suggesting the aggregate function as average. Okay, and similarly profit ratio is also percentage values. So if you drag it, it will take the aggregation average. Okay, so this is also semi-additive. We don't have any non-additive measures here because the decimal points we don't have here. So if you have, then it will not take any aggregation. So that will be a non-additive measure. Okay, so these are the measures and dimensions. Yes, any doubts?
No.
So in additive measures, whenever we are getting the direct value like 200, 300, 400, then that is the additive measure here. Like if I drag a cells, then it will not be in decimal, it will be directly like
Correct.
10 or 20 or some numeric value,
Exactly.
without
So
decimal.
it doesn't have
Whole
any
number.
decimal values here, so it is taking as a additive measure.
Semi-additive measures means
Semi-additive, all the percentage
we get,
values. So if you drag the discount,
okay, only the percentage.
maximum percentages as a best example we can say.
Okay.
Okay, so because it is not taking here sum, because sum of discount will not give a meaningful output, so Tableau is suggesting you to take the aggregate as average. So these all are semi-additives. Okay, and if you have any decimal values,
so I can understand in this way.
Yeah,
so can I understand in this way, like whenever we are getting average, when we perform normal drag and drop, then those are semi-additive, and whenever we are getting
that is a statement that you can make, because whenever you see, because by default Tableau will take sum. Okay, so if the Tableau is not taking it as a sum, that means that is not a additive measure. Okay, so if it is taking an average, then that means that is a semi additive measure. Okay,
and the last one is the
non-additive measure.
Semi-additive. Non-additive, in that we should have some, what should it contain, like some 0 point null values.
Correct. Okay. So we'll just discuss a little about data modeling techniques. Okay, so what is data modeling techniques? That means we are modeling the data. So whatever the data we have, because sometimes what happens, the data will be in a structured format, so we no need to do any modifications, we no need to do any modeling there. But sometimes what happens, you need to modify the data. That means you need to build some relationships, you need to do some cleansing, data cleansing has to happen, you need to change some arrangements in the data, within the data, right? So that data modeling is required. So how does that data modeling helps us is to arranging the measures and dimensions. Okay, so we use the schemas. So by using the schemas, we can arrange the measures and dimensions. Okay, so that arranging measures and dimensions is known as schema, and we use the schema to modeling the data. Okay, so we have basically three types of schemas. So one is star schema, second one is snowflake, and the third one is starflake. That is called mixed schema. So we'll see what is star schema first. So okay, so star schema. So let me show you what is star schema. So this is measure, and you have dimension 1, you have dimension 2, you have dimension 3, okay, and you have dimension 4. So what does that mean? So you have 4 dimensions. Okay, so you have 4 dimensions and you have one measure. So what happens when your dimensions connected to the measure directly? Okay, so you have the direct connection for your measures. So then what it is known as? It is known as star schema. Okay, so what does that mean? So all your dimensions are connected directly to the measure, and this is also known as fact table. So if all your dimensions are connected directly to the measure or fact table, then that kind of schema is known as star schema. Okay, if you see here, so if the dimensions are connected directly with the measure, then it is known as star schema. So we'll discuss in detail, like we have one example, live example. So if you see there, so working with KBC data. Okay, so here when we discuss about joins and relationships, then we discuss in detail about this schema. So what schema we can use and how it will be using in the data modeling. Okay, so we'll see that, but for now, just to have an understanding, you should know this. Okay, so let me reduce the size. Okay, so this is known as star schema. Okay, so dimensions are connected directly with the measure table. Now sometimes what happens, you have other dimensions okay, so this is dimension 5, this is dimension 6, dimension 7, and this is dimension 8. So you have other dimensions where they are indirectly connected to the measure. Okay, so if you see here, so the four dimensions are connected directly to the measures, and the remaining 4 are indirectly connected to the measures, right? So there is an indirect relation. So such model is known as, or such schema is known as snowflake. Okay, so if you see that example, snow schema, what is snow schema? So snowflake, if the dimensions are indirectly connected to measures, then it is known as snowflake. That means this is snowflake schema. If the dimensions are directly connected to measure, that is called as star schema. If the dimensions are indirectly connected to the measures, that is known as star flake. And what is snowflake? What is star flake? So star flake is nothing but the mixed schema. The mixing of star schema and snowflake schema is called as star flake. Okay, so combination of star and snowflake. So if we are combining the star and snow using bridge dimension, then it is known as mixed schema. Okay, so what dimensions will work as a bridge dimension is conformed dimensions will work as a bridge, because it will be sharing among all the segments. So we had seen what is a conformed dimension, right? So conformed dimensions are completely shared between the business segments. That means one dimension will be sharing between this dimension and this dimension. Okay, so when you are sharing one dimension between this and this, then what happens? You can merge of these two and you can create a mixed schema. Okay, so we'll see those in detail in the coming classes, but just to understand what is star schema, the dimensions are connected directly with the measure. And what is snowflake? The dimensions that are indirectly connected to the measure. And what is mixed schema? So we are using some bridge dimension and we are combining both star flake and the star schema and the snowflake. So if we are mixing this both using the bridge dimension, then that schema is called as mixed schema. Okay, so these are about the schemas. So if you see, if any interview topics comes in this, interview questions comes in this, so which schema gives a better performance? Why? So always star schema will give better performance because it has less number of dimensions, right? Less type of number of tables, and it has a direct connection with the measures. So since it has a direct connection, so it will give the better performance. But we will be using rare cases the star schema. That means this is a very basic schema, right? So all your data will not have the direct connections. So by default, your data will have some indirect connections to make. So in that case, what happens? You have to use Snowflake. So most of the projects is being used Snowflake. So if someone asks which schema you are using, you can say because of the complexity, I am using Snowflake. That means I am having dimensions which are indirectly connected to the measure table. Okay. So can we convert star to snow? Is it possible? Yes, it is possible. Okay. So this is snowflake. How to make this snowflake to star? By grouping this value by using some logical dimension. Okay, so if you group these two, what happens? Then it will become one dimension, right? And that will have a individual direct connection, right? There won't be any indirect connections because you are grouping them. So by grouping them using some logical, say it is possible by using logical dimensions. It means grouping the dimensions, but it is not recommended. So we will not recommend grouping the dimensions and using it. But if interviewer asks, can it be possible? Don't say it, no, it is not possible. You can say, yes, it is possible by using some logical dimensions, that is grouping the dimensions. But in the real-time scenarios, we will not recommend doing such. Okay. So this is about the schema, the data modeling. So any doubts in this?
No.
No.
Yeah. So we discussed about dimensions. What kind of what is a dimension? What all that Tableau will consider as a dimension, and what type of dimensions we have, right? And we had seen measures. What is being considered as measure, and what type of measures we have, like additive, non-additive, semi-additive. And we had seen the data modeling techniques, like what kind of schemas we have. So what is star schema, what is snowflake, what is mixed schema, right? So these are about today's topic. Okay, so with this we are done with dimensions and measures. So from tomorrow onwards we start creating some visualizations. Okay, so did you guys get the student key?
Okay, I get.
You got it?
Yeah, I got it.
Okay, fine. So have you activated?
Not yet.
Hmm.
I will activate today or tomorrow.
Okay. So how about you, Vicky? Did you get any idea?
No, I didn't get it. I will be just download. I will be just using the trial version.
Trial version you are using. How long you have still? How many days left?
10 days.
No, I don't have download. I will download. Already I downloaded 19.4. I'll download 19.3 version.
So don't work only on the trial versions, right? So try getting the student. You don't have anyone who is college going students?
No.
Like any of your relatives or friends, brothers, sisters?
No, like they are in school, not in college.
Okay. Okay, so don't worry. So anyhow, he got
One
it.
more thing,
So you guys can share it. Okay. So because one key can work on 2 machines, I said.
okay.
So let it get him the key. So you guys can share it. Use the
So one
student
thing,
version.
sir, if we are going with the student ID, so do we need to have the email address or the name registered with that person? I believe yes, because they will going to
They
check
will just verify
or not.
it. It's not required, I guess, because they will just validate. Because see, email ID, it is not a rule that you should have the same email ID, right? Someone will keep what? Let's say I'll give you an example. Okay, so postbox86@gmail.com. Whose email ID that is belongs to, right? That is my email ID,
Yeah,
and I am
it
a
will
college
not.
going student. Will you say no?
Yeah. No,
That's the
I
reason.
can't
So
promise.
email ID can be anything, no problem. You can do it with your email ID itself.
Oh, okay. One is the okay. Got it.
Okay. So maybe you need to give the names, like whatever the name it is there, right? So for you, you no need
Okay,
actually.
name
If you
should
have
be
the key, right? So the person who is applying for it first time, he should have all this information to be given. And once if you have the key, so how to get the key is, so go to the help, okay, about like manage product keys. So it shows that the product key here. So copy it and activate it. That's it. So it will activate to you. So that is my organization's key. And you, when you have the email, right? So you will get the email from the Tableau with the key, and you can enter that and you can activate your full version, like the student version, for 1 year.
okay. Got it.
Yeah.
So a person can use
So
two.
that's
He can
it.
use
I hope.
two user
Yeah.
can use the key.
Tell me. After 6 months, you are activating that same into the other mission. You will not get again 1 year. So the valid will be 6 months again, because already 6 months is been over. Okay. So
While downloading to the student version, directly suppose I got the key, then I can directly go and pass that key and I can use the full version, or I need to pass through the trial version and
not
then
required. That's what. So
once it
if you
expires,
get
then
the
I can
key,
ask.
right? So whatever the 16-letter key you get it, go to the help. You have the manage product buttons, like manage product keys option. You put the key that whatever you got it, and you click on the activate. So it will activate you 1 year duration.
Okay, got it. So in short, I can understand like I can go and download the 19.2 or 3 whatever,
Mm.
and then once I open it, I can go to the help and then over there I can pass the
Yes.
access
So
card
in the help,
and
you
I'm
have
good
the
to go
manage
with for
product
1 year.
keys. So go there. You give the activate button. Okay. So it will ask you the key. So give the key there and click on activate. So it will activate it. That's it.
Got it. So generally, how long will it take once I drop an email to
Generally they will take 2 days,
Tableau?
I guess, but you will get within 2 days.
Oh, okay.
Once if you apply all the like email ID, student ID card, upload front, back. Once if you upload that, they will take 2 days for verification. And once it is verified, they will send you the key immediately. Sometimes it will happen maybe 3 days, but most of the time you will get it within 2 days of time.
Got it.
Okay. So I'll send you these notes.
Yep.
The and images. Yeah. Okay, so we can look it into it, and from tomorrow onwards we'll move it into the practical sessions. Okay, theoretical part is over.
Okay.
Yeah. So thank you.